This session is on the importance of fiber inspection and cleaning. In image 1, we see a clean fiber and it's connected to another clean fiber. On the network, we have very low loss and very low back reflections. In image 3, we see a dirty fiber and it's plugged into a clean network. However, back reflections get 1,000 times worse compared to the clean fiber, and we pick up 4.6 dBs of loss. This connector now has a loss of about 5 dBs. If the system can't handle 1,000 times worsening in back reflections and a 5 dB hit, then the system is not working. At a minimum, it certainly is degraded. We say a UPC fiber is a flat or straight cut. Notice here at the end of a fiber, there is actually a dome. There is a dome to ensure that the tiny fiber in the one connector touches the fiber on the other connector. When we connect the Sam Charlie Lima Charlie together, it's held in place by plastic tabs, and we can actually hear the click as a connection is made. That is 2.2 pounds of force. But put 2.2 pounds of force over a circle that is 200 microns in diameter, which is the size of that dome, it ends up being thousands of pounds per square inch, and that can cause permanent damage. In this image, we see 3 big pieces of dirt, all bigger than the core, and note the core is mostly open with 1 speck of dirt down at the bottom. If the fibers are connected without removing the dirt, the big pieces of dirt explode into little pieces of dirt. Here's a second connection, third connection, and fourth connection. Now the big pieces of dirt are all little, and the small pieces of dirt, typically 5 microns or less, actually can get embedded in the glass and become permanent damage or cause pits and chips. If we touch the end of a jumper for 1/10 of a second with our hand, we will all apply a generous helping of skin oil. Connect that filthy fiber to a clean fiber. Note the clean fiber now has oil all over it, and note this ring that's about 200 microns in diameter. The high pressure takes the liquid near the edge and pushes it out to the ring. If we plug in a clean fiber, airflow comes across a connector and gets in the nook and the cranny where the two domes meet. If you disconnect the fiber and see that it's clean except for the coffee ring or halo, remove that halo, ensure it's clean, plug it back in. It's good for another 25 years. This piece of test equipment was supposed to transmit 10 gigabit traffic 30 miles, and the transmitter was so dirty it could not transmit 3 feet. Viavi says inspect before you connect. If the fiber is clean, plug it in. If the fiber is dirty, re-inspect it after cleaning, re-inspect it, and once it's clean, plug it in. If the dirt cannot be removed by wet dry cleaning and is permanent damage, that optics has to be replaced. Ensure both sides of a connection are inspected. A male jumper plugs into a female bulkhead. Both pieces of glass have to be inspected. What we're supposed to do is inspect the fiber, see that it's dirty, clean it, verify it's clean, plug in, we're good for 25 plus years. What we tend to do is have poor habits such as cleaning but not inspecting. We plug in, we have network problems and network outages. We use the OTDR, deploy somebody, find the problem, and spend money to replace optics. Contamination is typically the #1 cause of network outages and network problems. Proactive inspection reduces network downtime, reduces troubleshooting, optimizes the signal for today's traffic, and ensures it's ready to support future high-speed traffic and prevents network damage. Always inspect before you connect.